Stop for a moment. Feel. Reality is a thin layer of varnish over an ocean of impossible ideas. And you touch these ideas every day, without knowing it. You are about to understand why this simple touch depended on an idea so dangerous it had to sleep for 2 millennia, lest it burn the world down. It all began with a question that sounded like madness. What is the world made of? Imagine a time without laboratories, without telescopes, without proof. A time of sun on marble, of the sound of debates in the agora, when the only tool to understand the universe was the human mind. It was here, in the shadows of ancient Greece, that 2 thinkers, Leucippus and his student Demócritus, committed the most beautiful of intellectual crimes. The problem they faced was a knot in logic, a paradox posed by Zeno of Elea, who argued that motion was an illusion. To get from one point to another, Zeno argued, you must first cross half the distance, then half of the remaining half, and so on, in an infinite division that could logically never be completed. To solve this, Demócritus proposed a stroke of genius. What if matter could not be divided forever? If you take an apple and cut it in half and again, you would reach a final point, a fundamental particle, indivisible, in Greek, atomos. They proposed that everything, absolutely everything, was made of these particles. And for them to be able to move, they needed something even more radical, the void, nothingness. To the Greeks, the concept of nothing was a logical contradiction. How can nothing be something? But Demócritus insisted. For him, the universe didn't need gods to move it. All it required were collisions of matter, happening at random, within an infinite nothing. It was a simple idea, elegant, and for the established order, terrifyingly dangerous. For every great idea finds a great enemy. For the atom, that enemy was perhaps the most influential man of all time, Aristotle. He looked at the universe and did not see the chaos of Demócritus. He saw a cathedral of logic and purpose. For Aristotle, the void could not exist because nature detested it. The universe was filled with 4 elements: earth, water, air, and fire, each with its natural place, a home to which it longed to return. A stone falls because its home is the earth. Smoke rises because its home is the sky. It was an animate universe, with a soul, with a why. Above all, there was the ether, the divine substance of the celestial spheres, spinning in eternal perfection, moved by a prime mover, a final cause for everything. It was a universe made for us, poetic, comforting, and it gave humanity a central and noble place in the cosmos. And in a battle of ideas, the world rarely chooses the most correct one. It chooses the most comfortable. Aristotle's vision, adopted and amplified by Rome and, later, by the Church, became the absolute truth for centuries. The atom was crushed. The idea of the void, ridiculed, and the thought of Demócritus was condemned to a 2,000-year intellectual exile. For 20 centuries, the atom became a ghost, a whispered, suppressed legend. The fall of Rome and the Middle Ages saw the destruction of countless ancient texts. Knowledge became a small candle locked away in remote monasteries, guardians of a forgotten wisdom. Until in 1417, a man named Poggio Bracciolini, an Italian book hunter, a true Indiana Jones of his time, made a discovery that would change history. On an expedition to a German monastery, while searching a dusty tower the monks used as a latrine for old and unimportant books, he found a scroll. It was a copy of On the Nature of Things, the epic poem by the Roman Lucretius, which described in vivid poetic detail the atomist universe of Demócritus. The luck of a single man, on a single day, rescued an idea from the brink of eternal extinction. Poggio rescued the book from the filth and took it to Florence. News of the discovery spread like wildfire through Renaissance Europe. The atom was back, but it returned with an explosive force, challenging the very heart of the era's power, the miracle of the Eucharist. The doctrine of transubstantiation states that the bread and wine literally transform into the body and blood of Christ. But if the bread is made of immutable atoms, how can this transformation be real? The miracle would be just a rearrangement of particles, a heresy punishable by the stake. The idea was dangerous, but too fascinating to be ignored. In the 17th century, a French priest and scientist named Pierre Gassendi found a way to christen the atom. He tried to reconcile faith and reason, arguing the theory was not incompatible with God. God, in his infinite wisdom, would have created a finite number of atoms at the beginning of time, giving them their initial impulse to move according to the natural laws that he himself established. What was heresy slowly became an acceptable physics for the new age. But the final battle for the soul of the atom was yet to come, and it would have a martyr. His name was Ludwig Boltzmann. In the late 19th century, science was dominated by positivists like Ernst Mach, who said, "If I cannot see it, it does not exist." To them, atoms were a metaphysical fiction, a useful mathematical tool, but not real. Boltzmann disagreed with every fiber of his being. He dedicated his life to proving that temperature, pressure, everything we feel, was the statistical result of the motion of billions upon billions of invisible atoms. Imagine Boltzmann's loneliness, to see the world with a clarity no one else possessed, to see the invisible dance in a hot cup of tea, to understand the heat-death of the universe in a candle's flame, only to have his colleagues, the greatest scientists of the age, treat him as a poet, a mystic, not a physicist. Truth can be a prison when you are its only warden. He fought in congresses, he published papers, and he gave us the equation for entropy, the formula that explains the arrow of time. But the scientific community rejected him with overwhelming cruelty. They called his work useless fiction, his lectures were boycotted, his ideas ridiculed. Exhausted and plunged into a deep depression, feeling his life's work had been in vain, Ludwig Boltzmann took his own life during a holiday trip in 1906. Just a few years earlier, in 1905, a young patent clerk named Albert Einstein had published a paper on Brownian motion, using Boltzmann's ideas to, once and for all, prove mathematically that the atom was real. Shortly after, the experiments of Jean Perrin confirmed it visually. Boltzmann died without seeing the dawn he, more than anyone, helped to create. And once proven, and then mastered, that useless idea took its revenge in the most ironic and spectacular way possible, by becoming the foundation of everything. 20th century science dived into the atom, and what it found was an even stranger and emptier universe. Rutherford's model revealed the atom to be like a miniature solar system, a tiny nucleus with electrons orbiting in an immense void. If an atom were the size of a football stadium, the nucleus would be smaller than a grain of sand at its center. The rest? Nothing. Then, Niels Bohr showed that electrons couldn't just orbit anywhere. They existed in fixed shells and jumped between them, a quantum leap, releasing or absorbing energy. Reality wasn't continuous. It was granular. And it got even stranger. With Schrödinger and Heisenberg, the electron stopped being a spinning ball and became a ghost, a cloud of pure potentiality. You could not know where it was and where it was going at the same time. The very act of observing changed reality. The foundation of all matter wasn't solid. It was uncertain. It was mighty wonderful. And it was this understanding of quantum mechanics that gave us the semiconductor, the transistor, the laser, the building blocks of the entire digital world. Want a concrete example? Your GPS. For it to work, a network of satellites 20,000 kilometers high needs to talk to your phone. This conversation depends on time measured with almost divine precision. The clocks on these satellites are atomic clocks. They don't use gears. They measure the immutable pulse of a single type of atom, cesium-133. By the laws of physics, a cesium atom anywhere in the universe will always oscillate or vibrate the same number of times, 9,192,631,770 times. When it does that, one exact second has passed. It is the heartbeat of our time. And this precision is so absurd that it must be corrected by Einstein's theory of relativity. Earth's gravity, as Einstein predicted, distorts time. Time on the satellites, where gravity is weaker, passes a tiny bit faster, about 38 microseconds per day, than it does for us here on Earth. It may seem small, but without this correction, based on how matter and energy warp the fabric of space-time, your GPS would be off by more than 10 kilometers every single day. All of this entire dance of quantum physics and relativity is only possible because one day, a man dared to think about the invisible. That debate, that poetry, that suicide. All of it is right here, in the palm of your hand. What you have just watched was not just the story of the atom. It was chapter 1, the first echo from a void that is full of stories. How many other ideas like this are around you right now, disguised as common things? The screen on which you watch this video, the music you hear, the very structure of the language we use to think, all are monuments to thinkers who dared to look into the void and feel not fear, but curiosity. There are other ideas like this, other ghosts that shape our destiny. They hide in the mathematics of a card game, in the psychology behind a color, in the architecture of a song you can't get out of your head. They are everywhere, waiting to be seen. They are not just curiosities. They are the unwritten rules of our fate, the silent grammar of reality. And here, in this space, we are going to learn to read that language together. And the beauty, the beauty behind it all. That is the story we are here to tell. This journey has only just begun. To join our expedition and not miss Chapter 2, subscribe and be sure the bell of discovery is activated. Think in the void.